Hello, geometry students. We're here to talk about the Pythagorean Theorem. It's a classic, and I'm working from this book here, Geometry from Jurgensen. I'm in chapter 8 right here, and I'm not going to hit all the questions, but I'll hit some of the main ones, and hopefully through this you'll have a better understanding of how this theorem works. All right, this Pythagorean Theorem, it's really, as simple as ABC. A squared plus B squared equals C squared. And in your typical, this only works for right triangles, but oh my God, this thing right here is going to be used all through geometry, pre-calculus, trigonometry, calculus. It's over and over, many branches of mathematics. A and B are known as the legs. They're on either side of the right angle. And C is always opposite the right angle. And that's it. So A and B can be interchanged. It doesn't matter. A, B, switch them up. Doesn't matter. But C has got to be opposite the right angle. Most important. And so we have this triangle here, this right triangle. We know because you have the little square right there. And I'll just put 3 and 4 in for A and B. I'll substitute them. So that would be 3 squared plus 4 squared equals, in this case, C squared. But we're going to call it X. Because in the problem for number 1, it's X in that Oh, and by the way, hypotenuse is this longest side. Hypotenuse. Hypotenuse. It's the longest side of a right triangle. So to solve for X, let's square 3. That's 3 times 3, which is 9. Plus 4 squared is 4 times 4, which is 16. That's equal to X squared. And 9 plus 16 is 25, which is X squared. And what we have to do is, to find the value of X, we would take the square root of X squared. Now, by the way, if you took the square root of, let's say, I don't know, I'm thinking like 6 squared. Well, that would be the square root. 6 times 6 is 36. And so the square root of 36 is 6. So the square root of 6 squared is 6. If I did the square root of 7 squared, well, that would be the square root of 7 times 7, which is 49. And the square root of 49 is 7. So hopefully you kind of see this relationship, 6, 7. So it really just doesn't matter if you have X squared. The square root of X squared is just going to be X. You see, so that brings us down to, okay, great, we have X, but we have to take the square root on the other side, because what you do to one side of the equal sign, you also have to do the other side. And the square root of 25 is 5. And that means that length of X is 5. Now, perhaps typically you could say, well, the square root of 25 could be positive 5 or negative 5, because negative times negative is a positive. But it doesn't make sense to have a negative length. You're not going to have a negative 5 units length. It's only positive. So we're only going to take the positive root of this. Here's the second question. Another right. All of these are going to be right triangles. And I'll go in with my A squared plus B squared equals C squared. I'm going to fill in the C. And the C is opposite the right angle, so that means it's X. So this is going to be X, but it has to be squared, and we have now the legs. It doesn't matter. 12 can go first, 5 can go first. I'll just go with 12. So 12 squared plus 5 squared. 12 squared is 12 times 12. That's 144. 5 squared is 5 times 5, which is 25, and X squared remains X squared. 144 plus 25 is 169, which is X squared. And like we did before, we have to square root both of these so we know what X is. And X is the square root of 169, the positive root of it, which is 13. Because 13 times 13 is 169. Okay, so here's another one. And things have been switched up a little bit because we're no longer solving for the hypotenuse in this case. We're solving for one of the legs. So I'll show you how that works. We have A squared plus B squared equals C squared. I start like this. every time. And I'm putting in that hypotenuse first. In this case, it's 11. It's always opposite the right angle. So 11 squared. And the legs, doesn't matter. Let's call the first side x. That'll be a. And the other one has to be 9. So plus 9 squared. Okay. X squared, I'll keep that as x squared. 9 squared is 9 times 9, 81. 11 squared is 11 times 11, 121. Now we got to solve this equation. You got to subtract 81 from both sides. And you get x squared is equal to, that's 0, that's 40. Okay, so we have to take the square root of both sides. The square root of x squared is x. The square root of 40 is... what I got to do at this point is it's going to be some funky decimal. It's an irrational number. So what I'm doing is I'm thinking, well, 40 is 4 times 10. And how did I come up with 4 times 10? Well, I'm thinking of factors of 40 that are perfect squares. And if you don't remember what a perfect square is, it's like 1 squared is 1, 2 squared is 4, 3 squared, I'll just do a few of them, is 9. 4 squared is 16. 5 squared is 25. And I'll stop at 6 squared is 36. So here's the first few, right? And I'm thinking, 40 right here is 4 times 10. And 4 is one of those perfect squares right there. So I'm going to use that. And the square root of 4 is 2. So a 2 is going to come out of here. And so that means now the answer is going to be 2 times, but 10 didn't make it out. So 2 times the square root of 10, and that is our final answer. All right, now we have number 7. And this one kicks it up a little bit. Now we're going back to finding the hypotenuse. I know this because I'm looking opposite the right angle, and that's the x right there. And I got to use a squared plus b squared equals c squared. And I'll plug in a and b. A would be 4 squared. B would be 4 times the square root of 3. But that all has to be squared. So if I do this, it kind of looks like just the square root is being squared. So I got to put parentheses around all of that right there to show the entire thing's being squared. And then that equals c squared. Okay. Oh, actually, maybe I should make it x squared because we're solving for x. Okay, so 4 times 4 is 16 plus, now when you do this, you got to square the 4 and square the square root of 3. So this is called, okay, let me do this over here. This is called 4 times the square root of 3 squared. Okay, so if I do 4 squared, that's going to be 16. And then the other part is the square root of 3 squared, which is just 3. Yeah, that's exactly what it is. So it's 4 times 3, which is 48. So this is going to be 16 plus 48 equals x squared. And 16 plus 48, let's see. This kind of helps me think sometimes. So 14, that's 64 equals x squared. Oh, I should have known this. So now we have to take the square root of x squared, which is x. And we have to take the square root of 64 because you have to do the same thing on both sides of the equal sign. Taking the positive root, that would mean x is equal to 8. Nice. Okay, number 10. Now... It's a rectangle cut in half, which is 2 triangles. So hopefully you can see those 2 triangles right there. And I'll just isolate the triangle by drawing it. And it's something like this, where this is the right angle. The hypotenuse is going to be 15. One of the legs is 12. And this side's x, so that means the other side is x too. Oops, kind of glitched right there. So we need to use the Pythagorean Theorem, a squared plus b squared equals c squared. And the c, most important, that has to be isolated. That's opposite the right angle. That's 15. That's 15 squared. And we have a and b, so 12 squared. would be one of the legs, and x squared. We're solving for x. Let's square everything. So that's 144 plus x squared equals 15 times 15 is 225. Now I'm going to solve for x squared. So subtract 144 from both sides. And x squared is equal to, well, that's 81. Super. I have to take the square root of x squared, which is x, the square root of 81, which is 9. And that is the answer, 9. All right, so number 18 in the same section says the perimeter of a rhombus is 40 centimeters, and one diagonal is 12 centimeters long. How long is the other diagonal? All right, so it's probably best to draw a rhombus. It has 4 equal sides. It's a parallelogram. It's a special type of parallelogram that has 4 equal sides. So I need to make a parallelogram, something like this. So parallelogram has opposite sides equal, and rhombus has 4 equal sides. There's also so this is same as this, same as this, same as this. And we're talking about the diagonal. So here's one diagonal, and here's the other diagonal. And there's something that I remember about the diagonal of a rhombus, I guess, is the diagonals meet at 90 degrees. So now we have 4 right triangles. The perimeter is 40 centimeters. So if the perimeter is 40 centimeters, if I divide that by all 4 sides, that means each side is 10 centimeters. Okay. One diagonal is 12 centimeters long. So let's say that this one here is 12 centimeters long. So I believe that not only is it the diagonals of a rhombus are perpendicular bisectors. So perpendicular, so that means they meet at 90 degrees. One here meets that, but they're also bisectors. So if if the whole thing's 12, that'll split it into 6 and 6. So we can take one of these triangles, and I'll take one of the triangles. And this is 10, the bottom right one, and here, and here. And this was 6. So now we're trying to solve for x. And that'll be that right there. Oh, this is a tricky one here. So let's go with the Pythagorean Theorem. A squared plus b squared equals c squared. The c has to be 10. And a could be 6. Oops, I want to make that red. 6 squared, and then plus b squared would be x squared. I'm getting fancy here. 6 squared is 36. Oh, I meant that to be white. I want that to be white right there. And then x squared equals c squared. God darn it, this colors are going all over the place here. So equals 100, right? Because 10 times 10 is 100. Okay. I'm not going to get fancy with these colors anymore. Drive me nuts. So if I were to solve for x, I would have to subtract 36. Let me give myself a little bit of room here. And I would have x squared is equal to 100. That's 64, I believe. So if I take the square root of both of these, x is equal to 8. 8 times 8 is 64. But the answer isn't 8, is it? X is equal to 8. So that means if I go back into my drawing here, x is equal to 8. And that means that this other side, x is equal to 8. How long? The question, though, was how long is the diagonal? So the diagonal would have to be 8 plus 8. And so the answer would have to be 16 centimeters because the set originally was in centimeters. So there you go. All right, here's number 27. We're getting a little bit more advanced now. And oh my God, I can already, okay. There's there's these things called Pythagorean triples, which I'll talk more about in the next section. And I can already see, knowing the Pythagorean triples, watch for the next video. I already know that this side right here is 8. I already know it. Oh, can I try this color right here? Is that better? It's 8. I don't know. Nothing's working right there. It's a very neutral. It's 8. But I'm going to use the Pythagorean theorem to show you that it's 8. And I need to find that side first before I can find x. So let's go with a squared plus b squared equals c squared. We're going to end up using the Pythagorean theorem twice on this problem. The plan is, in order to find this side, I have to use this right triangle first to find this length. And then I'm going to use this right triangle here to find that length. Because we can't just jump right in. It'd be nice if we could use this whole thing, but this isn't a right triangle right here. These two are right triangles. So and what you need to know also is that's a right angle too. So the hypotenuse is going to be 10. That's 10 squared. And then one of the legs is 6. And I don't know what the other side is. Let's call this b right here. So that's going to be b squared. So 6 squared is 36 plus b squared equals 10 squared is 100. And I would subtract 36 from both sides. And b squared is equal to 64. So b, if I take the square root of both of these, that means b is going to be 8. And just like I said, it's 8. Knowing the Pythagorean triples is a total cheat code. I'll show you in the next video. So, all right. We have to use the Pythagorean theorem again for the middle sized triangle. And I'm going to use it for this triangle right here. So we have a squared plus b squared equals c squared. And c has to be x, because that's the hypotenuse. And a, well, that could be 8. And b could be 15. Got to square them both. 8 squared is 64. 15 squared is 225. And then you have x squared. So 64 and 225, what, that's 9, that's 8. That's 289 equals x squared. And I would have to take the square root of both of these, right? So the square root of x squared is just x. And the square root of 289, I happen to know, is 17. Don't judge. I just remember these things. So, you know what? And if you do it a couple hundred times, you would remember it too. So, x is, that's it. X is 17, solved. All right, so here's another one. This is one of the more difficult ones, and you got to kind of think. You have to think three-dimensionally on this one. We want to find x here. So the plan is I got to use this triangle right here. And there's x, that's one of the legs, and here's the hypotenuse, but we're missing this side right here. And they give us another right triangle here, and they give us two sides here, so we can use the Pythagorean theorem for this little triangle to find this length right here. So this length is the hypotenuse of this side, but on the other triangle, it's a leg. So we're going to be putting this length in the Pythagorean theorem in two different places. So here we have a squared plus b squared equals c squared. And for this triangle here, these are legs because they're on either side of the right angle, and that's opposite. So 9 squared plus 12 squared. 9 squared plus 12 squared equals c squared. Okay, 9 squared is 81. 12 squared is 144 equals c squared. If I add these up, that's 5, and that's 225 equals c squared. Take the square root of c squared, and that's c. Take the square root of 225, and that's 15. So this length is 15. Okay, now I'm going to set this aside, and hopefully I'm going to set it aside. Let's see. Okay, that gets set aside, that'll get set aside, and this gets set aside right here. And we need to separate this. And we got to do the Pythagorean theorem again. So a squared plus b squared equals c squared. And so now 15 and x, they are legs in this case, and the 25 is the hypotenuse. So that would be 15 squared plus x squared equals 25 squared. I'm going to give myself some more room here because I don't really need this, do I? I already did this stuff. So this is, oopsie. Okay, so we have 15 squared is 225 plus x squared. 25 squared is 625. So now we subtract 225 from both sides. And we get x squared is equal to, what, that's 0, 0. That's 400. And now I have to take the square root of x squared, which is x. The square root of 400 is 20. And that's it. That's the answer. 20. All right. I think this will be, I'll do one more. I'll do one of these here where it says, in these exercises, 33 through 36, you're given the dimensions of a rectangular box, and they give you a sample here. Sketch the box and find the length of the diagonal of the box. Okay, maybe I'll just go with this 34 right here, or the E. Maybe I'll do the E. No, that's a cube right there. I'll do 34. Okay, so for 34, the dimensions are, so we have a box, and I like to just draw the box like this, and then I will draw 3 parallel lines that are about the same length, and there you go. So 2 sides are 5, so this is 5 and this is 5, and the other side is 2. So there's the 3 dimensions. And we need to find the length of the red. Maybe I'll go from here to there. So that's kind of funky. Let's see. If I did this here, then what I see is I would have to do the Pythagorean theorem twice. So I see that, well, we can look at the sample too, because they do a pretty good job with this. They have, I guess I'll call this A. No, I'll call this side. Oh boy, it's tricky to draw it too, you know. So I'll do maybe blue, like that. And so actually what I could do is I can call this B. I can call this A, and I can call this C. So that length like that. So now when I draw this again, as we have this, I would do this. I would have this is A, and then I'll go B with this. That's B, and this is C. And all the while, that's a right angle. We know that A is 5, but we don't know what B is. And in order to find B, we're going to have to do this. We're going to have to use this side, and I'm looking at maybe I'm looking at this right here, and maybe I'll make this dashed just like it is. And this side, since that's 5. Oh, this side right here is 2, so this side is 2 also. So that's 2 right there. Okay, and I know that this front right here is 5, and then B, this side right here, we're trying to figure that out. And since it's a box, it doesn't look like it right now, but that part's 90 degrees. So this right here, I've drawn here, but you have to use your imagination that this is it's a box, so it's a right angle. So we would use the Pythagorean theorem in here. So it'd be a squared plus b squared, squared equals, and then I'll do this where it's, oh God, I chose b. This blue b squared, okay? I'm sorry, that is both b. But, yeah, that's a poor choice. But anyway, what we would have is a squared is 2 squared, b squared is 5 squared equals, and then this b squared, not that it's b, it's the hypotenuse in this case. So we have 4 plus 25, right? Because 2 times 2 and 5 times 5 equals b squared. And that's 29. So this would end up being 29 is equal to this b squared. So the square root of this, right? So b is equal to the square root of 29. And I don't even know what the square root of 29 is. I'm just going to keep it as 29. Or the square root of 29. So this is the square root of 29. Great. Hey, we're ready to go. Because now we can attack this triangle. We can attack this triangle right here because we know one side is 5 and the other side is square root of 29. So we now find this side of C. So I'm just going to go with, no. I'll just keep it all white. A squared plus b squared equals c squared. So a squared, A is going to be 5 in this case, plus b squared. B is the square root of 29, and that's going to be squared, equals c squared. So 5 squared is 25, plus the square root of 29 squared is 29, equals c squared. 25 and 29, that's 54, I believe, equals c squared, and the square root of, so the square root of c squared is c, and the square root of 54, I'm thinking, are there any perfect squares? 9 times 6, right? Isn't 9 times 6 equal to 54? And we can take the square root of 9, that's 3, so this ends up being 3 times the square root of 6. And that should be it. Hey, I hope you found this helpful. I spent some time going through all those exercises. And if you got that book, you're golden. And if not, it's easy to find. I'll put links in the description for it. And if you got any more questions about the Pythagorean Theorem, shoot me some comments and questions, and I'll be happy to respond. So, till next time, enjoy. And so it's time to wrap things up for this. If you got more questions, add it in the comments. Let me know how it goes for you. And thanks for watching. Look out for the next one. We'll be talking about the Pythagorean triples.